Hi guys, we're going to jump into surface area today. Specifically, we're going to look at prisms and cylinders, and we'll get into other polyhedron later. So let's start with a reminder of what a prism is. It is a polyhedron, multiple-sided three-dimensional figure with two congruent and parallel bases. Remember, bases doesn't mean they're sitting on the bottom. Bases in this 1, 2, 3, 4, 5 pentagonal prism are the two faces of the polyhedron that are parallel and congruent. So it would be this pentagon and the back pentagon are congruent and parallel, so they are the bases. We will also have a lateral face. So in this case, I'm going to have 5 lateral faces. 1, 2, 3, 4, 5 on the bottom. And then we're now calling these edges that we had before where those lateral faces intersect, those are called lateral edges. Okay, so we'll have 5 lateral edges as well. When we're looking at prisms, though, we got to remember that we have 2 parallel, congruent and parallel bases. So if I'm looking at this figure here, normally we want to start calling this the base because that's where it's sitting. But I don't have another rectangle that is parallel to this rectangle. It is not a base. So my bases are my 2 parallel and congruent triangles. So this would be a triangular prism because I have 2 parallel and congruent bases. So if I'm looking at this figure over here, I've got a triangle and a congruent triangle opposite it, but those triangles are not parallel. This is not a prism. So it does not apply when we're looking at finding surface area. Okay, so we got a couple pieces that make up surface area. So lateral area, since these are my lateral sides or lateral faces, your lateral area is just the area without bases. So it's when I am looking all around this three-dimensional figure and not including the area of the bases. So it's just the side figures. That's your lateral area. The surface area is all sides and bases. So that surface area is if you are an ant that is crawling around or surfing on my figure. My ant can crawl all the way around. He can crawl on top of here. He can crawl underneath because the ants can crawl upside down, and off we go. So that's the surface area. It's everything an ant can crawl on. So we're going to look at what happens if I chop this figure in half, like a cross section. What becomes my surface area then? So we'll look at that when we're seeing it in class. Okay, a couple other things we got to remember though. I have a triangular base. Perimeter goes around the figure, and height is always the perpendicular distance. So altitude, you're going to say it called altitude, which equals height, which equals my perpendicular distance between bases. Okay. Let's see. You have a couple different types, 2 types of prisms. You have a right prism, and that just means that your height is inside, located actually in the figure. So if I have a rectangle and another rectangle back here, I have 2 parallel congruent rectangles that makes up my prism. Your height is right here inside the prism. And that's my height. at a right angle. You could also have, let's say it's not, we'll worry about that later. So let's look at the other type. It's called an oblique prism. It's when you're outside. Height is outside. Let's say we had slanted. Start with a slanted one. I'm going to come up here and start with a slanted one. Remember how we do these? And we got some dashes here. I need my height to be perpendicular. So my height of this prism needs to be calculated outside the prism. Okay? So just like we were doing earlier when we were looking at areas, you can find your height. It's still the perpendicular from base to base, and my base length here is still the same. I don't add in this stuff. I just have to drop the perpendicular outside so that I can find the accurate height. All right, let's put all these together. You have a base. I'm going to call this is my polyhedron here. So it's a rectangular prism, and I'm going to call this A, B, C, and D. Those edges, A, B, C, and D. So I'm going to have another set, A, B, C, and D, because they're congruent and parallel. That's my base, so I'm going to call this base. And the perimeter of the bases will get me to the lateral area. So if I were to take this base and put it over into a net, this is my edge, A, B, C, and D. Those are the edges A, B, C, and D up at the top. The height is the perpendicular height, so in my three-dimensional figure, that's my H. So here's my H. When I'm looking for lateral area, so I want the area of just the sides without the base, so this is area without bases, I look for the H is height, and P is perim of the bases. Gets a little funky. So since these are my bases, this is my area. So I know height times base is the area of just this rectangle anyway. And I have it again also, base times height here, and a base times height here, and a base times height here. I can just add up all of these and multiply by the height and get one big lateral area. Okay. If I want to find the surface area though, so this is my lateral area side, if I want to find the entire surface area, that's including the bases, I already know what my lateral area is, so I'm going to find lateral area first. Again, if I take this and make it into a net, this is A, B, C, and D. I still have my height. The surface area formula is lateral area. That's where the LA comes from. That's a lateral area, which is perimeter times height, perimeter of one of the bases times the height of the figure, and 2 big B. This is 2 times area of bases. Since I have 2 congruent bases, I have 2, and big B represents base area. So let's play with this so it sticks a little bit. Find the surface area of the right prism. So we want to make sure we know what we're looking for. So once I know I'm looking for surface area, I know I should always start with the formula. Those of you that are skipping formulas are having trouble on the tests. Is lateral area plus 2 of those base areas. I know lateral area though is my perimeter times the height. And I still have 2 times the bases. So if I'm going to look at this base area, That's a triangle. So I got to go figure out B separately. So I'm going to do that in a little bit. I know that the perimeter is the perimeter of the base. So my P is going to equal the perimeter of my base, 6, 6, and 6. So I've got 6 plus 6 plus 6 equals 18. So I know my perimeter is 18. I've got to find the height. It is not the height of the base. This is the height of the prism. The height of the prism is the perpendicular distance between the two bases. This is my height. So we got to get in the habit of identifying some stuff first. It's perimeter of a base, height of the figure. So I'm going to do height of figure up here. Okay, so I know my height is 8 plus 2 times the area of the base. I don't know what my area of the base is, so I need to go figure it out. So B is going to equal, what shape do I have? Triangle. So I have 1/2 base times height. 1/2. Now that I've got baby B, that's the base of my triangle because I'm trying to find the area of my base. The base is 6. I have an equilateral triangle. Or I know if I drop in my altitude, it cut it in half. So now I have a right triangle with 3 and 6. I have the hypotenuse and a side, so I should use Pythagorean theorem. 6 squared equals 3 squared plus, I'm going to call that the height that we're looking for, h squared. 36 equals 9 plus h squared. 27 equals h squared. H is equal to the square root of 27. We simplify that and find that it's 3 rad 3. Or I could use 30, 60, 90 rules as well. So now we know the height is 3 rad 3. Half of 6 is 3 times 3 is 9, so I know the area of the base of that triangle is 9 rad 3. So I'm going to go back over here and put 9 rad 3. Because that's what big B is. Base of area, base of triangle. Something like that. And then I just simplify at that point. I've got 18 times 8, whatever that is, plus 18 rad 3. So if I wanted an exact answer, I would have to leave it as 18 times 8, which is 144, plus 2 times 9 is 18 rad 3. That's my exact answer. It's approximately, this is in surface area, so we're looking at inches squared, which gives me approximately 175.2 inches squared. These can take a while. You need to go step by step by step so that you don't mess up any of the pieces so that you can get the correct answer. Alright, let's try another one. You guys are going to do this practice, but get in the habit of sketching them real quick. So it says find the surface area of a right rectangular prism. So we're going to sketch it real quick. So I know I have a rectangular prism. So I'm going to, and it's right, so I know it's inside. Where's my other rectangle here? Height of 5 feet. Height is the distance between the bases. These are two congruent parallel bases, or I could define these as the bases as well. We got base, so that's right, so I'm going to call that 5. Length of 11, we'll call this 11, and width of 4. Okay, you guys pause the video and see if you can find the surface area of that. Okay, I got 238 feet squared. So work it through and see if you can get that. Let's talk about it tomorrow if we're still stuck. All right, last thing I want to look at today is a cylinder. So we're going to look at cylinders. Cylinder, let's remind ourselves, is a polyhedron with two congruent parallel, let's just write that out, parallel circular bases. So we're on the same track, only this time instead of being a polygon on either side, we have a circle. So I can draw a circle, and then I can draw some straight lines to represent the height between the next circle, draw a little arc underneath it, and then I can put my dashes in to represent the back. I have two parallel congruent bases. The height is always defined as the perpendicular distance between the bases. So that's my height. Cylinders don't always have to be up and down though. Sometimes you're going to see a circular. I've got my sides of my cylinder. I'm going to put my sideway ones are harder than the other ones. I'm going to put my other piece down here. This really should be dashed, and off I go. This would then be my height, because it's between the bases, the perpendicular distance. Just like we had in prisms, we can also have oblique. So these are called right cylinders, because the height is actually in or on the cylinder. You can also have oblique cylinder. The process is the same for finding the area. We just have to be careful with identifying the height, because the height is still the perpendicular distance between the bases. So I need to figure out the perpendicular distance to find the height. All right, let's try some of these. So the surface area of a right cylinder. We know the bases are big B in this case. Big B, remember, capital B means base area. In this case, it's always going to be a circle, so pi r squared. Circumference, don't forget circumference is 2 pi r, and our height is the perpendicular distance between those things. And typically they identify it from the center of the circle to the center of the circle for the height. But you can also find it on the edge as well. Okay, the surface area is the same. We're still going to have a lateral area. If we take a look at the lateral, remember lateral is without the sides, and if I roll this out, I end up with a rectangle. So my lateral area is the perimeter of the base, which is 2 pi r, which is my circumference, and then the height. That's my lateral area. My surface area then is the lateral area. That's my lateral area plus the base area. And I still have two bases. So I know I have a rectangle for my lateral area. And I also know that I'm going to have a circle of some sort here that has the same radius as the circle below it for my bases. Okay? So surface area equals lateral area plus 2 of my big B. And remember, big B means base area. Let's go try. Find the surface area of the right cylinder. So I'm looking for surface area. I start with formula. Surface area equals lateral area plus 2 times my base area. The lateral area of a cylinder is a rectangle. The lateral area is a rectangle that has a height and a base that is the circle circumference. So I know my lateral area is going to be height times 2 pi r. plus 2 times the base area. The bases of a cylinder are a circle area. So 2 times pi r squared. So I'm going to substitute these in and then go substitute in the pieces that I know. I know the height between my parallel and congruent bases is 5. So I'm going to put in 5 times 2 times pi times my radius. Well, they gave me the radius is 4 times 4 plus 2. Now I need the area of my bases. The area is a circle. Pi r is radius, 4 squared. Get in the habit of setting up your equations and then substituting them in. Make a lot less mistakes. 4 times 2 is 8 times 5 is 40 pi. 4 squared is 16 times 2 is 32 plus 32 pi equals 72 pi. Units is meters squared. That's my exact answer. My approximate is 226.2 meters squared. Okay. We're going to do one more of these together and then you'll go back up and do practice. Tonight, or for today, you need to do the practice here. We're going to do that in a minute. And then you need to do 1, 2, and 3. The last page of the lecture we will do in class tomorrow for practice. Alright, so let's do example 3, and then you will be done with the lecture. It says find the height of the right cylinder shown. So I'm not looking for surface area right now. It says find the height. I need to figure out what this height is. So I'm going to have to work backwards, which has a surface area of 198 millimeters squared. I'm still dealing with surface area. I'm still dealing with a cylinder. So I know I have the surface area equals 2 pi r squared plus 2 pi rh. Okay, so what I did was just jump. I know I have 2 of my base areas plus I have the height times the circumference. So this is really equal to 2 base area plus the lateral area. That's all I did was substitute in the pieces since cylinders are always the same. So my base is 2, base area here would be 2 pi. They gave me the radius, 2.8 squared, plus my lateral area, which is the rectangle, is 2 pi times 2.8, and h is what I'm solving for. So I got to eventually get h by itself. They gave me the surface area, so I substitute in my surface area, 198.8. Then I simplify and solve. It's all about algebra now. 198.8 gets carried down. 2.8 squared times 2 is 15.68 pi. Remember, always leaving pi until the very end. Plus 2 times 2.8, which is 5.6 pi. Still have my h. I am going to simplify at this point by approximating this, so I can move it over here so I can start getting h by itself. So I'm going to take 198.8 in my calculator and subtract, because I'm going to subtract from both sides, 15.68 pi. I end up with 149.54 is approximately, because I had to approximate with pi, 5.6 pi h. Then I'm going to divide both sides by 5.6 pi so that I can isolate h. In my calculator, I get h is approximately 8.5 in millimeters. Okay, so this is algebra skills, folks. So if you're struggling with this, you need to make sure you're coming in to get some extra help. Go back and work your practice above, and then 1, 2, and 3. And then pause the video and check your answers. All right, there's the answer for your first practice up above. And then down below, let me scan out so you can see all of those together. All right, I will see you in class tomorrow.